At what rate is the squirrel accelerating at time t equals 2? So we are again going to look at the graph of this squirrel moving along the line and figure out, in this case, at what rate is it accelerating at time t equals 2. So pretty simple. Let's go ahead and go back and look at the graph, and then we'll figure this problem out. We want to figure out what the acceleration of the squirrel is at time t equals 2. Now, remember, this is the velocity of the squirrel at a particular time. So at t equals 2, we know its velocity is -2, right? This is the v of t axis. But what is this acceleration? Another example would be like at time t equals 9, the velocity is 2. But we want to know its acceleration at time 2. So I'm going to use the color orange, and I'm going to circle this right here, draw an arrow, and write acceleration. Or just excel and put a question mark there. So what is this acceleration there? Well, recall that acceleration is the derivative of velocity. So what do you think about this point graphically? How do you find the derivative of a point given a graph? If the answer that you said is slope of the tangent line, you are correct. Now, if you remember though, when a graph comes in at a v, that's a problem, right? You actually can't find the slope. So what does that tell you about the squirrel's acceleration? It doesn't have one, right? So pretty much already gave the answer away, and it's pretty simple. But if you still want to learn more about that, go ahead and follow along with me as I go through the steps here. So here's the question again. At what rate is the squirrel accelerating at time t equals 2? Step 1, we want to interpret what is given verbally as a graphic expression. We ultimately want to focus on the point 2, -2 on the graph, which we just circled. Step 2, interpret the verbally stated question as a graphical expression. Considering that acceleration is the slope of the tangent line, derivative of velocity, we need to determine the slope of the tangent line at t2, -2 of the velocity graph, what we just talked about. Step 3, consider the appropriate motion relationship chart. Well, in this case, we're just going to focus on this one. Again, we said acceleration is the derivative of velocity. So again, I can draw an arrow and say that a of t is equal to v prime of t. And that's pretty much it for step 3. Step 4, solve the problem using the graph adhering to the curve or slope of the tangent line. In this case, it's the slope of the tangent line because acceleration, again, is the derivative of velocity. So the slope of the tangent line at 2, -2 is undefined because the graph is pointy there. I like to use this word pointy. My students laugh, but it's the best way to remember it, in my opinion. It reminds me of like a witch's hat or something. Step 5, answer verbally. The acceleration of the squirrel is undefined at time t equals 2 because the graph of its velocity is, you said it, pointy there at time t equals 2. This is actually a very simple question. It's with a very simple solution. Anytime you have where two straight lines meet in a graph and it's pointy, that means that the derivative is undefined. In this case, acceleration is undefined. Now, let me just give you, let's say it wanted to know this acceleration at t equals 3. What you would do is you could find the slope of that graph, right? Just by going up 4 and over 2, its acceleration would actually happen to be 2 at t equals 3. I'm even going to try to write this right here. And the units there would be feet per second squared. Okay, so that's just an example of if you actually had to find the slope, but you already knew that because you've been taking math for so long, right? All right, that's it for this acceleration problem given the graph. If you have any other questions about it, let me know.